Hello students, today we will go through one more problem of conversion. In the last sessions we had studied how to convert a problem if you have greater than equal to sign or less than equal to sign, and if you have equals to sign. So this is the third type of problem. So we will go through this. So the question is that write the dual for the following primal. Minimize z equal to 3x1 plus x2 plus 7x3, and the constraints are x1 minus 2x2 plus 3x3 less than equal to 10, 3x1 plus 5x2 minus x3 is greater than equal to 9, minus x1 plus 4x2 plus x3 is equal to 6. And the difference is that in this problem you will have, instead of x1, x2, x3 greater than equal to 0, they will give you x1 is unrestricted or x2 or x3, any either of the one or any two. So here in this question you have x1 is unrestricted. So this is the third type of problem which you get in the question paper, and this is very important question which has appeared in your 2006 paper. So let us see how to solve such problems. Okay, so the solution is that firstly this is a minimization problem. You have to convert it into a maximization. If it was a maximization and no need, you have to directly solve it. Since it is a minimization, you have to convert it. Okay, so maximum of z dash equal to minus 3x1 minus x2 minus 7x3. You have to just multiply minus 1. Okay, after that the second step, just see, since you have converted into a maximization problem, for a maximization problem, see here, all the constraints should be of the type less than or equal to. But here if you can see, the first equation is okay, it is less than equal to, so no need to change the first equation. Whereas if you see in the second one, here it is greater than equal to, so first you have to change this one. So how to change it? Again multiply minus 1. So after that, when you multiply minus 1, you get, instead of plus 3x1, you write minus 3x1 minus 5x2 plus x3 is less than equal to minus 9. So this you have converted. The first is done, second one you have converted. Now coming to the third equation, you have minus x1 plus 4x2 plus x3 is equal to 6. So what you have to do during this condition? I have told you, if there is equal sign, you have to convert this into one pair. Okay, that is of the pair will consist of one less than equal to sign and another is greater than equal to sign. So when you express this in that form, so the first you express in the less than equal to form, so it will become minus x1 plus 4x2 plus x3 is less than equal to 6. Okay, and if you see this equation holds good for a maximization problem. It should be less than equal to, but when you write another pair that is greater than equal to, it will be minus x1 plus 4x2 plus x3 is greater than equal to 6. So again this will not go good. Okay, the condition will be violated. So again you have to convert this equation into a standard form, that is into a less than equal to form. So what it will become, again you have to for this particular equation, for this pair, so you'll have a pair. Okay, see they have given, convert the third constraint with equal sign as a pair of inequalities. So this is nothing but, once you should write less than equal to, and another time you have to write greater than equal to. So this less than equal to holds good for maximization problem, but this one you have to change. Again, to change this one you have to multiply minus, that is minus 1. So after multiplying minus 1, you get x1 minus 4x2 minus x3 is less than equal to 6. So now all the the equations are in the standard form. This first one was already in standard form, second one you have changed, and the third one also you have changed. Now the next step is, since x1 is unrestricted, so what do you mean by unrestricted? So unrestricted is nothing but, it is a variable where the values are not confined in any way. Okay, so in some LP problems, what happens, we assume the real value, but an unrestricted variable can be expressed in terms of two non-negative variables by using the substitution. Okay, so usually it will have real values, but whenever they give it as unrestricted, which means that you have to substitute in terms of two non-negative variables. We will see here. So if you can see here, so since they have given x1 is unrestricted, so you have to substitute in the place of x1, you have to just substitute x1 dash minus x1 double dash. Okay, so if it was x2, then you have to substitute x2 dash minus x2 double dash. Okay, this same will follow for every problem, and you have to write the condition that x1 dash is greater than equal to 0 and x1 double dash is greater than equal to 0. So this is the only difference whenever they give the variable as restricted. Then step 5 is nothing but you have to convert this. So here just see, maximization z equal to, you had 3x1. So in that place you have to just substitute. For example, here you had z dash equal to minus 3x1 minus x2 minus 7x3. So now since x1 is given as unrestricted, you have to substitute that value, that is nothing but x1 dash minus x1 double dash value here. So when you substitute that value here, you get minus 3x1 dash plus 3x1 double dash minus x2 minus 7x3. Okay, and the constraints will be again in place of wherever you have x1. See here, in the first constraint you have x1 here, you have to substitute x1 dash minus x1 double dash. Then in the second constraint you have minus 3x1, again you have to substitute x1 dash minus x1 double dash. Similarly here, so after that you get this particular equation. Okay, after substituting. Next, the next step, that is step 6, is again you have to transpose. In the last session we had gone through how to transpose that. Okay, all the rows will be converted into columns and columns into rows, and the values from the right hand side will go to the objective function, and the values from the objective function will come to the right hand side. And this is nothing but, this is whatever you get the equation, they have just represented in the matrix format. Okay, this is not necessary, but in case if you know, you can just go for this. It's not compulsory. Then finally what you do, you have to change this. The maximization will be, and here just note down, here they have used y1, y2, y3, y4, but in the last session I had taken it as w1, w2. So anyone will go. Okay, you can take anyone because both are nothing but they are dual variables. Okay, so then finally you have to change that this thing values. Okay, so finally you get minimize z dash equal to 10y1 minus 9y2 plus 6y3 minus 6y4. See here, this right hand sides they have taken it as objective functions, and this values whatever you get here, that is 3, 3, minus 1, 7, they have taken here. Okay, this is about, and you can see here, and you have to change the signs also. I think you have to change from greater than, if it is greater than, you have to change it as, make it as less than, and less than will go to